Analyze the chemical environment at the end of Step 2. In Step 2, the solid copper phosphate, Cu3PO4, 2, precipitate is dissolved in a highly concentrated strong acid, 3.0 molar HCl. This dissolution reaction frees the copper and phosphate ions into solution, where the phosphate protonates to form phosphoric acid, H3PO4Cu3, PO4. 2 plus 6H to the power plus gives 3Cu to the power 2 plus 2 H3PO, for we are told that the resulting solution has a pH of approximately 1. Since pH equals log H to the power plus, a pH of 1 means H to the power plus approximately 10 to the power minus 1 molar equals 0.1 molar. This high concentration of hydrogen ions is primarily due to the excess hydrochloric acid used to dissolve the precipitate. Analyze the successive ionization steps of H3PO4. Phosphoric acid is a weak triprotic acid that ionizes in 3 sequential, increasingly difficult steps. First ionization. H3PO4 is in equilibrium with H to the power plus H2PO4 to the power negative quad K. A1 equals 7.5 times 10 to the power minus 3. Second ionization. H2PO4 to the power negative is in equilibrium with H to the power plus HPO4 to the power 2. Quad K. A2 equals 6.2 times 10 to the power minus 8. Third ionization. HPO4 to the power 2 is in equilibrium with H to the power plus PO4 to the power 3. Quad K. A3 equals 4.2 times 10 to the power minus 13. Compare relative concentrations using the equilibrium constants. To determine which conjugate base is present in the lowest concentration, we look at how the ratio of ionized species behaves under a high H to the power plus concentration of 0.1 molar for the first step. H2PO4 to the power negative over H3PO4 equals K, A1 over H to the power plus. Approximately 7.5 times 10 to the power negative 3 over 0.1 is equal to 0.075. This indicates that only a small fraction of the H3PO4 has ionized to H2PO4 to the power negative. For the second step, HPO4 to the power 2 dash over H2PO4 to the power negative equals K, A2 over H to the power plus. Approximately 6.2 times 10 to the power negative 8 over 0.1 is equal to 6.2 times 10 to the power minus 7. The concentration of HPO4 to the power 2 is less than 1 millionth of the H2PO4 to the power negative concentration. For the third step, PO4 to the power 3 dash over HPO4 to the power 2 dash equals K, A3 over H to the power plus. Approximately 4.2 times 10 to the power negative 13 over 0.1 is equal to 4.2 times 10 to the power minus 12. The concentration of PO4 to the power 3 is 12 orders of magnitude smaller than the already minute concentration of HPO4 to the power 2. Establish the final concentration hierarchy. Combining these ratios yields the following relative abundance for the phosphorus species in the highly acidic solution. H3PO4 Gg, H2PO4 to the power negative Gg, HPO4 to the power 2, Gg, PO4 to the power 3. Because each successive deprotonation is heavily suppressed by the high concentration of hydronium ions, a stark manifestation of the common ion effect on polyprotic systems, the fully deprotonated phosphate ion, PO4 to the power 3, has the absolute lowest concentration among the species listed. This corresponds to option D. The correct answer is option D, PO43-.